Alright students, today we're going to study some physics, EHM physics, and we're going to focus on strand 1, lesson 1, and our substrand is going to be on heat energy. We're going to be talking about heat energy today. So what are we expected to be learning today? The key words today: energy, heat energy, heat transfer, combustion, radiation, convection, and temperature. Learning outcomes for us today, we're going to be describing and explaining how heat energy is transferred by conduction, radiation, and combustion. And of course, we also have to learn how to recognize the difference between the word heat and the word temperature. Before we get to some activity, we need to refresh our memory from year 9 and even lower level in year 8. So we're going to refresh our memory, and you should already be knowing what is energy, what sources of energy are, what are the energy forms, and what is the unit of measurement of heat. Some background information for us before we get to the activity. Hot and cold are relative terms that we use to compare how things feel when they have more or less of a certain kind of energy. In this case, we are talking about heat. Heat, when we say heat, it means heat energy. When something is hot, it has more energy. When something is cold, it means it has less energy. Heat energy is a form of energy that is transferred by a difference in temperature. I want you to note the difference here. When I say heat is transferred by a difference of temperature, because we are going to be finding out the difference between heat and temperature later. Heat energy always flows from a warmer object to a colder object. Heat and temperature, as we already know, are two different things. What are the difference, or what is the difference between heat and temperature? Heat is the energy stored inside something or an object. Temperature is measurement of how cold or hot that something or object is. Now, our learning outcome or our substrand today is on heat energy transfer, how heat is transferred. Now, there are 3 ways in which heat energy can transfer. The first one is conduction, which is the movement of heat energy from one solid molecule to another because of their temperature difference. Convection is the flow of energy that occurs when warm liquid or gas expand and rise. Radiation is when energy is transferred by waves or infrared waves, which can travel through a vacuum to its point of absorption. Now, when we say vacuum here, we're not talking about vacuum cleaner. We're talking about an empty space. Okay? I will talk more about that later on. Now, let's get down to some activities. Activity 1 is called the ice rake. The material we need is very simple. Just a small ice tube and a sealable plastic bag, normally called Ziploc bag, like this one here. You can open and then seal it tightly to airtight it. And a small piece of ice tube. That's all you need for this activity. Now, all you have to do for this activity is put the ice tube in the bag, seal it up very tight, and then you're going to have 5 minutes, just 5 minutes, to look around you and find a way to melt the ice into liquid. You are not allowed to open the bag and take the ice out to try and melt it in over a flame, or try and put it in a pot of boiling water. You have to be creative and find a way to melt it. Then we come back, we will ask some questions. Now we're back. 5 minutes later, obviously you were trying to melt the ice using sunlight. Remember, you were told you cannot use a flame or heat flame or even boiling water. So obviously you were trying to melt it using sunlight. Now let's have a look at some questions to find out what you were trying to do. Question 1. What type of heat transfer is this activity? Question 2. Why? What do you think was happening when you tried to melt the ice? And which has the higher temperature? The ice that you started off with, or the water that the ice melts into? Some answer. Question 1. What type of heat transfer is this? Obviously, this is radiation. Why? What do you think was happening? You were trying to melt the ice using sunlight. The heat energy from the sunlight travels from the sun by a wave or sun waves, and when it reaches the ice block or the ice cube, it breaks up the molecules of the solid ice. It moves them further apart, and the more energy, more heat energy the ice cubes absorbs, the further apart the molecules break up and eventually melt into ice. So the ice cube has absorbed via radiation the heat energy from the sunlight. Which has the higher temperature, the ice cube or the water? Obviously, it is the water. The ice cube was colder, which means it has a lower temperature. And the water that it has melted into is now has now absorbed heat energy, and therefore the temperature is higher. It means it's a lot more warmer than when you first started with the ice. Now, that's radiation. Let's move to activity 2. Activity 2 is called a spiral. Materials you need are aluminium foil or paper, candles and matches, strings, or even the thread or the filler, scissors, cellulose, pencil, or in color. Now, you can see here, this is all we need. You don't need anything expensive, very simple materials. You need a candle, the paper, box of match, cellulose, filler, or even a string, and I have here a protractor. Now, why do I need a protractor? Because we need to draw a circle. You remember this from mathematics? How to draw the circle. Put it in the center of the paper. Make sure you mark where you put the center. Draw the perfect circle. And then you draw from around the center a spiral. You have a spiral like this, use the scissors, cut it up around the drawings, leaving the center, okay? And so after you cut it up, you make sure you make a hole in the middle. You put make a hole in the middle over here, and then you put the string through it, tie the knot, and then you should have something like this. That's the spiral. You can use any paper. thick or thin paper, color paper to make it interesting, and even foil. You can even try it with foil. So let's see what this is all about, what this activity is about. We're going to light the candles. We have the candle here, it's lighted. Remember, when you do this on your own at home, please make sure you have adult supervision. Okay, you don't want to burn down your house, so make sure somebody older is with you when you do this activity. So now that we have lighted the candle, the next thing you do, hold your spiral with the string and bring it on top of the lighted candle. Watch what happens. As the air gets warmer and warmer between the spiral and the candle flame, the spiral should be spinning. Supposed to spin. Watch it spin a little bit more now. Be patient and watch it spin. Can you see it spinning? It's a bit slow at the moment, but this is one factor we must always consider when doing a science experiment or science demonstration. There are other factors affecting the success of the experiment, so make sure the room that you are in has no outside influences like the wind or the aircon on. You should not have any of those outside factors. You watch it spinning. It's a bit slow than expected, but that is what is happening. Okay. So, are you having fun? This activity, as I say, is very, very simple. Before we ask the question, let's turn our candle off for safety. Okay, so what are our questions for activity 2? What types of heat transfer is this activity? And what has caused the spiral to spin? So, this activity number 2 is a demonstration of convection. Convection in gas. What has caused the spiral to spin is the warm gas that has rise up. The warm gas or the gas molecules from the flame has expanded and rise up. As it rises up in contact with the spiral, it moves the spiral and makes it spin. And then the process continues because when the hot air rises, the warm air goes down, gets heated by the flame, and then rise up again. So the process is like that. And so the spiral keeps on spinning for as long as the candle is lighted. You get that? Alright, so that's convection. Let's have a look at activity 3. Activity 3, again, very simple materials are needed. Just a toothpick, again the candle, and the teaspoon. That's all we need. A toothpick and a spoon. And of course the candle that we use for activity 2 and a box of match. What are we going to do for this activity? We're going to light the candle. And then you see the melted wax in the candle, you ghost the toothpick with it. The tip of the toothpick with it. And then you let it dry for a while to make it hard. So the toothpick is now coated with the hardened wax from the candle. The next thing you do is you put the toothpick on top of the candle flame, making sure that it doesn't get burned and it's near the flame, no contact at all. Use a watch, time how long the heat will travel to your hand. Do you think the heat will ever travel to your hand through the toothpick? That's something we're going to find out later. Now, how about the teaspoon? Teaspoon is metal. It's either stainless steel, silver, or even aluminum. Using the teaspoon, you do the same thing as you did for the toothpick. You put it on top of the candle. Using the watch, time how long the heat will travel from the bowl of the spoon that you're heating up to the end which you are holding. Compare the time when you heated up the toothpick and the time that you are heating up the teaspoon. Very simple demonstration for activity 3, and we are going to find out what this is all about. Okay, so for activity 3, what types of heat transfer is this activity? And to find out more on what this activity is about, we ask, which is the good heat conductor, the toothpick or the spoon? And why do you think cooking utensils or cooking spoon that we use at home have plastic or wooden handles? Now, let's have a look at some answers. This activity is obviously conducting. You were trying to demonstrate that heat can be transferred by conducting in solid. And you were trying to compare that the heat transferred by a wood represented by a toothpick, it takes longer for the heat to be transferred from one end to the other. Whereas the teaspoon heated up faster from one end of the spoon to the other end which you were holding. Now, when you were doing this activity, you should also note that the heat travels faster in the teaspoon compared to the toothpick. So that means the spoon is obviously a good conductor. And so that's why we use for cooking utensils the metals, aluminium or the stainless steel pot, stainless steel spoon, because they are good conductors. And to prevent the person cooking from burning, most cooking utensils spoon or spoon have plastic or wooden handles, so that you don't get burned when you are cooking at home. So those are some simple activities to demonstrate to you the three ways of heat transfer. So, let's sum up. What have we learned today? What have you learned today, children? Have a look at the sum. Heat is a form of energy. We now know heat is a form of energy. Heat and temperature are two different things. Heat energy can be transferred by sun rays, radiation. Heat energy can be transferred by gas or air, which is convection. And heat energy can be transferred by vibrations of atoms or molecules of solid, and that's conduction. In other words, radiation is associated with waves. Heat travels through radiation by waves. The sun rays are actually waves, and they travel through vacuum. That means there is no direct contact with the object that you are trying to heat up. Convection is heat energy is transferred by the difference of density of liquid gas particles caused by a change in temperature. Note here we are associating convection with density. We will be talking later about density in physics in later strands. And so this is important to note the relationship here of heat energy associated with density. What was happening in convection in our demonstration was when the hot air rise, when the gas particle or hot the air gets hot, it has become less dense. So that's why they rise. And the cold particles of the air or the gas are more dense, and that's why they sink down. You get that? So we associate radiation with waves. Okay, we're talking about sun rays, okay, or infrared rays. And we associate convection with density. The less dense air rise, and the more dense air go down. The last heat transfer method we will studying today is heat energy. Heat energy is transferred by contact. Note the word contact here. Okay? Direct contact of heat with the object that you are trying to heat up. So in other words, when we're talking about conduction, it's a transfer of a hot particle or the heat energy by vibration of particles of the solid. So when this particle gets heated up in contact with the next one, then this next one gets hotter, and then it transfers to the next one. Okay? So direct contact of particles, it moves the heat energy along the solid or the metal. That's our heat transfer methods that we have been talking about today. But it's all around you. If you look around you, all these heat transfer methods are around you. And one classic example you find in your home is cooking. If you have a look at the pot, you're cooking soup. And the pot is sitting on the oven. The pot is in direct contact with the elements of the oven. You know, so down here at the bottom of the pot, which is in contact with the element of the oven, that's conduction. Heat is transferred through the pot from the elements of the oven to the pot via conduction. Inside the pot, where you're boiling water or soup or whatever, that's convection. When you start off with cold water or room temperature water, turn the oven on, and then the soup gets heated or the water gets heated because hot liquid has rise and warm liquid go down until all your ingredients in the pot is cooked. And radiation, if you bring your hand near the pot, not touching it, you can actually feel the heat, right? You can actually feel how hot the heat is from the pot. And so your hand is actually feeling the heat transfer by radiation. Okay? So that's a simple classic example of the three methods of heat transfer in real life. Sometimes later on in physics we will be talking about other applications in the weather and many other applications of heat transfer, but that's something you will need to stay tuned for. Okay, so before we end today, let's have a look at some challenge questions. Okay, everything at the end of each lesson, we need some challenge questions to think outside the box, to make us relate to what is happening, what you have learned today, to what is happening around you. Okay, so what are our challenge questions? Would it make any difference if you had crushed the ice instead of using the ice cube in activity 1? I want you to think about this challenge question. You don't need to answer me now. We will answer all these questions in our next lesson. Okay? So think about it. If you have crushed the ice into smaller pieces, would it make a difference? Would it make a difference if you had crushed the ice to the rate of reactions, to the speed of melting using sunlight? Think about that. So question number 2, would it make any difference if you had used a Bunsen burner instead of a candle? Remember the spiral in activity 2? It's the spin spiral. If you had used a Bunsen burner or even a study light instead of a candle. Think about that, and you can even investigate using YouTube or any other sources you can find information on, and then we will talk about it in the next lesson. And our last challenge question for us today is, do you think the size of the toothpick and the spoon would make any difference? Do you think it would make any difference if the toothpick is thicker and longer and the spoon is thicker and longer? Would it make any difference to activities number 3 we did today? So pause and think about those 3 questions, and then when we come back in the next lesson, we will find out the answers. Hope you're having fun learning physics today. See, it's not that boring. It's fun. So, until next lesson, so far safe.